let's play around with the units and see. So we know what's the equation? Just the general classic noble gas equation. Well, what's just the classic equation in this section? Yeah, V equals that,
RNT over P.
Or PV equals what?
nRT.
Yeah, this is how I remember it, and then you can manipulate it to get it however you want. Because like, it looks like you have a million equations, but you don't. You have one equation, and you just flip it around to solve for what you want, right?
Yeah.
Okay, so you're saying when you are solving for molecular weight. So, what's the equation you have for that?
This one we have molecular weight equals grams times RT over P.
Okay. Now let's look at y. Let's get that equation from this equation, okay? And let's just do it in units. So what are the units of P?
Atmospheres.
Good. Oh, ATM. I've got money on the mind. Oh wait, no, it is ATM. Atmospheres.
Yeah.
I don't know what I'm thinking. Long day. Okay. ATM, atmospheres times, what's the units for volume? Liter. Okay, good. Units for N, what does N represent?
Just the weight.
Should be the number of moles, right?
Moles.
Mm-hmm. So, number of moles. Is that right? Number of moles? Times R.
And then R is the constant.
Mm-hmm. And R is a constant in a few chemistry equations, right? And sometimes 8.314, and other times it's 0.821. So which one is it in this case?
This one is 0.0821.
Good.
And so, do we always use that? Because you put that, but you also put 0.08206. And so,
I
it's
don't.
just easier to use the rounded one.
Yeah, I don't know. I don't know what he'll want. It's probably, if you're gonna learn one of them, you might as well learn the one that has the most sig figs,
Okay.
just so you can play it safe. I kind of had this one in my head.
That he taught us the other one, but then every time he does an example,
He
writes
does that.
down.
Yeah,
So that's why I just kind of been.
iffy. Yeah,
Which one do we use?
I would maybe err on the side of caution and just learn the more precise. So, but yeah, good. And you know, the one that's 8.314, whatever, they just have different units. But they're the same number, but because the units are different, it comes out to be a different number. Does that make sense? You can derive one from the other. So, and what are the units for this? R.
Isn't that grams per moles?
No. Does it show you on your sheet?
Oh, is it liters times atmosphere over moles times Kelvin?
Yes. Yep. Do you remember this? Are you using the other R right now, or did you use that? Okay. We won't worry about it because it has a little bit different units. But if you're not learning that right now, we'll talk about it. Okay. And then what about temperatures in Kelvin? Good. Okay. So we want molecular weight, right? What is weight? I mean, I guess it kind of. Well, how could we manipulate this equation to give us what we want? What is molecular weight? Like if you were going to say molecular weight of something, whoops, what would be the units you'd attach to it?
That'd be grams and moles.
grams per mole probably. Okay. So how can we play with this equation and get that?
I guess the moles would cancel out already, wouldn't they?
Sorry, let me check something. Okay, he's saying, so grams divided by molecular weight. So if we had grams divided by, we said molecular weight was grams per mole, right? Really, if we wrote that properly, it would be grams times moles over grams, right? Grams would cancel. And you just have moles. So that's how he introduced grams in. Because if you look through here, you're not going to see any.
Yeah, that's what I was wondering.
Yeah. So he introduced this. He just said molecular weight is grams divided by grams per mole. Even though it seems redundant, it's so that you're left. You don't change the units. So let's just say. Let's just get moles by itself.
Okay.
So we would have number of moles equals divided by what?
1.0821 liters ATM over moles Kelvin.
Good.